Guys, in the today morning session, we discussed about what is one-to-one relation, and we developed one application on one-to-one relationship. So when we go for one-to-one relationship, parent record will have relationship with child record. So we have taken the example of a person and passport. We have taken the example of person with a passport. Okay. Now, today, here we are going to learn how to implement one-to-many relationship. Okay, so we are going to understand how to implement one-to-many relationship. One-to-many relationship. What is the meaning of one-to-many relationship? Parent table record will have relationship with child table records. Parent table record will have relationship with child table records. Child table records. So when I say one EMP can have multiple addresses. One employee can have multiple addresses. One author can publish multiple books. One author can publish multiple books. And we can say one college will have multiple students. Okay. And we can say one university can have multiple colleges. So these all relationships comes under one-to-many only. One-to-many only. Okay. So one table in the one record in the parent table will have the relationship with multiple records in the child table. Okay. Good. Then we have designed entity classes also in the morning. So I have taken one entity called the employee entity. Employee entity contains ID, name, and salary. And address entity is available. Here, city, state, country details are available. And we are establishing that relation. So one employee can have multiple addresses. So if you see from the employee side, one employee is having list of addresses. One employee is having list of addresses. Okay, good. Then if you see from address side, so one address can belongs to one employee. So from employee side, it is one-to-many relationship. From address side, this is many-to-one relationship. So in this example, we are storing employee ID as a foreign key in the address table. To represent that foreign key relationship, we are using join column. So address is related to this employee. Address is mapped to this employee. That's why here in the one-to-many, we are giving mapped by is equal to EMP. Cascade all. Cascade all nothing but whatever the operation we perform on the parent table will be reflected in the child table also. So whatever the operation you do on the parent table, that operation will be reflected in the child table also. Now, let us generate setters and getters here. Let us generate setters and getters here. And for address also, let us generate setters and getters. Employee is one entity. Address is one entity. The relation between the employee and address is one-to-many relationship. Very good. Next one. Let us create repositories for this employee and address. So I'm going for a package, new interface. So I'm going to create repo. One repository required for employee table. Okay. And another repository required for address table. New interface, address repository. So these are JPA repositories. Let me extend the properties. Extends from JPA repository. So this is going to talk to employee entity, and the primary key of the employee is integer. Okay. Then address also will do the same thing. It is also going to extend the properties from JPA, and its entity is address. Its entity is address. So employee entity, employee repository, address entity, address repository is available. You need to understand how we are writing these annotations. This is important. One-to-many relationship with address. From address, if you see many-to-one relationship, and where we are storing foreign key. Employee table, employee ID, we are storing as a foreign key in the address table by using join column annotation. Now, let us create one service class to perform CRUD operations on the table now. Okay. So service class, I'm taking a service class with a name called EMP service. Now I want to represent this as a service. For that, I'm using one annotation called @service annotation. Let us inject repositories into this service. Private employee repository, which is EMP repo. Let me go for auto wiring. Next one, address repo, private address repository is available. Auto wiring for address repository also. @auto wire. Now, I want to insert the data. I want to insert employee with multiple addresses. So let us write a method, save employee, public void save employee data. Now, so employee is having addresses, right? One employee can have multiple addresses. One EMP can have multiple addresses. One employee can have multiple addresses. Okay. So first let me set the address data now. Address object I'm creating. Address A1 is equal to new address. When you go for address entity, now let me set the type of the address also. Private string address type. So it is a permanent address or present address, we can mention that. Let me add one extra column for that. So extra column I added address type. Now here create one address object A1 dot set city. I'm setting the city as some Guntur, and A1 dot set state Telangana some value, and A1 dot set country. Okay. Now we are setting these details. Then I'm going to set this data as permanent address. Set type, address type, which is permanent address for the employee. Similarly, one more address will be available for this employee. So this is A2. Okay. A2 dot set city, state, country, and the type we are going to do. So in the city, Hyderabad, Guntur, here it is AP, here it is Telangana, India, and this is present address. Okay. So address 1 and address 2. Two addresses are available. These two addresses belongs to which employee? Let us create employee object. Employee E is equal to new employee. Then E dot set name of the employee. Set name of the employee. E dot set salary of the employee. Okay. Then set name and set salary of the employee. ID will be auto generated with the generated value. ID will be auto generated. One address A1, another address A2, another record employee. So currently I created two address objects and I created one employee object. Now I want to represent association. I want to represent association. How we are going to represent this association? Associating EMP with the addresses. Associating EMP with the addresses. A1 dot set EMP. This address belongs to which employee, and A2 dot set EMP. This address belongs to which employee. A1 address belongs to employee, A2 address also belongs to employee. I am associating address object with the employee object. A1 dot set EMP, E a2.setEmp of E. Then next one, associate addresses to the employee. Associating here, employee object I associated with the address. Now here associate addresses employee. Associate addresses with the employee object. Now, how do we associate addresses with the employee? Here, E dot set address. Address is a list, right? One employee can have list of addresses. So I'm going to take arrays dot as list of A1 comma A2. Okay. So here for address object, I'm adding the employee. Here for employee object, I'm adding the addresses. This is called association. We are representing the association among the data. So if you see employee list of addresses, one employee can have list of addresses. One address that belongs to employee. So in the service class, what I am doing here, I'm creating one address object with the data. I'm setting the address data for the employee. Here also, I'm creating another address. One is permanent address. Second one is present address. Then I created one employee object also. Here, I am setting employee data to the address. This A1 address belongs to which employee? This A2 address belongs to which employee? These two addresses belongs to the same employee called Ashok. So A1 dot set employee of employee object. A2 dot set employee of employee object. Finally, associate addresses with the employee. So for the employee, I'm passing both addresses A1 comma A2. So with this, our association is complete. Then finally, save parent record. Then finally save the parent record. Employee repository dot save of employee object. Whenever you save the parent record, then automatically the child records also will be saved. Whenever you save the parent record, then automatically child records also getting saved in the database table. Are you guys able to understand? Are you guys able to understand? How we are setting the data now? Are you guys able to understand how we are setting the data now? Address and employee. Okay, good. You can save the child records also. You can save the child records also. If you save the child, then first parent will be inserted. It is a standalone application. Data we are setting manually. In the real time, data will come from the form. Okay. So this is a standalone application. We are setting the data manually. In the real time, that data will come from web application. Form will be available. From the form, two address objects will come. One employee object will come. That data we are going to save into database table. Okay. So you need to understand how we are associating this data. How we are associating this data. Are you able to understand how we are associating that data? Are you able to understand how we are associating that data? Perfect. Good. So currently we are taking this data as a standalone. We can convert this into REST API also. We can take this data from the REST API and we can insert the data into table. We'll convert this into REST API as well. Currently it is a standalone application which is taking address data and employee data. Now go to this one, test class, and run this application. So before that, YML file, okay, database information is available. Go to start class of the Spring Boot. Go to the start class of the Spring Boot. Then get the service object. Get the service object. Context dot get bean of employee service is available. context.getBean of employee service is available. Then let us call the method service.saveEmployee. Now we need to check in the database, the tables, what are available and how the data will be inserting in the database table. Show tables. Today morning, we created person table and passport table. Now you see show tables, only person and passport tables available. So when I run this application, it should create employee table and address table. It should insert the data into employee table and address table. Here I have used DDL update. So if the table is not available, it is going to create that table. If the table is not available, it is going to create that table. Good. Now let us run this application, run as root application. See the console, how the queries are going to get executed. Yeah. Now you see table address is created, table employee created, foreign key constraint is added to the table. Added, it is creating the address table first, then it is creating the employee table, then it has altered our address table and added foreign key constraint for the address table with the employee ID. Then it inserted parent record first, then it inserted child records. So let us go to the table and verify show tables. Now you see address table and employee table is available. Let us select the data. Select a star from address. Okay. Yep. Now you see that two records inserted into address table along with the foreign key, which is employee ID. Along with the foreign key, which is employee ID. Then select a star from employee table. Select star from employee table. So employee ID, employee name, employee salary is available. ID is 1. When you go for address table, two records inserted along with the employee ID. That means foreign key relationship is available in the address table. So this address, present address, permanent address, these two addresses are belongs to which employee, we are able to understand by using the employee ID. So association mapping is working now. Association mapping is working. Whenever I insert the parent record, along with the parent record, my child records also getting inserted. Along with the parent record, my child records are also getting inserted. Okay, let's try to retrieve the parent record and see the behavior. So in the morning session today, when we retrieve the records, when we insert parent, child also inserted for one-to-one relationship. When we retrieve parent, child also retrieve by using left join. When we retrieve child, parent also retrieve using left join. When we delete parent, child plus parent getting delete. These are our observations in the today's morning session when we worked with one-to-one relationship. Now, let's understand our observations in the one-to-many relationship. So in the one-to-one, when parent inserted, then child also inserted. When parent record is inserted, then child records also inserted. Now let us retrieve the parent record now. Public void get employee. By using employee ID, we want to retrieve employee record. Employee repo dot find by ID. I'm just giving employee ID as 1. And I want to observe how the query is getting executed. When I'm trying to retrieve the employee record from the employee table, I want to see how the query is getting executed. In the today morning, in the one-to-one relationship, when I retrieve the parent record, when I retrieve the person record, along with the person, passport record also retrieved by using left join. Now, when I retrieve employee record, whether it is going to retrieve address records also or not, I want to check it. Okay, good. Get employee record, employee repository dot find by ID is 1. Go to this start class, then service dot get employee object. I'm trying to retrieve employee record from the table by using employee ID. So in our scenario, employee is a parent table, address is a child table. Child table is having foreign key relationship with the parent table. Now I am retrieving parent table record and I want to see child records will be retrieved or not. Run as boot application. Check the query which is printing on the console for this one. Go to the console and verify what is the query it is getting executed. Yes, select employee. Now guys, observe clearly. When I'm retrieving the parent record, child record is coming or child record is not coming. You see the query. Is there any join operation available in the query or join operation is not available in the query? Any join operation available in the query or join operation is not available in the query? Join operation is available in the query. Join operation is not available in the query. Join operation is available in the query. Join is not available. So there is a difference, right? In the morning in the 1-to-1, when I retrieve parent, child came by default with the left join. But when do you go for one-to-many, child record is coming or child record is not coming? In the 1-to-1 relationship, when I retrieve the parent record, child retrieved by default. But when you go for one-to-many, when we retrieve the parent record, child record is not retrieved. When parent is retrieved, childs are not retrieved. Childs are not retrieved. I retrieved parent record, then only child record, only parent record is coming, child records are not coming. Are you able to understand this? Yeah. Sir, why childs are not coming? So due to performance issue, right? One parent can have 1,000 childs also. When you retrieve the parent, if child is also coming, that means unnecessarily we are retrieving all the data. For that one, here, if you want childs also, then you can see fetch is equal to eager. So earlier, I did not specify the fetch type. So earlier in our parent table entity, there is no fetch type. So that's why it is retrieving only parent record. Now I am going to specify fetch type as eager. Now I am specifying fetch type as eager. Now observe the behavior, same application, just I am changing fetch type to eager. Now see the behavior of our query. See the behavior of our query now. Run as boot application. Run as boot application. Clear the console. Same program I am running. Now you observe, is there any difference in the query or there is no difference in the query now? Now it is retrieving address records also. Left join with the address, it is retrieving employee data along with the address data. Now join query is executed. Now it is retrieving parent record and child records also. Now it is retrieving parent record and child records also. What is the conclusion here, guys? So whenever I am retrieving the parent, childs are not retrieved by default. Childs are not retrieved by default. So here in one-to-many relationship, default fetch type is lazy. Default fetch type is lazy. Only parent will come. Default fetch type is lazy. Only parent will come. When I'm retrieving the parent, I want the childs also. Okay. If we want to retrieve if we want to retrieve child records also, if we want to retrieve child records also along with the parent, then we have to set fetch type as eager. Okay, if we want to retrieve child records also along with the parent, then we have to set fetch type as eager. Are you guys able to understand? Are you guys able to understand? When we insert the parent record, then child records also inserted. When we insert the parent record, then child records also inserted. When parent is retrieved, childs are not retrieved by default. In one-to-many relationship, default fetch type is lazy. Only parent will come, but not childs. If we want to retrieve child records also along with parent, then we have to set fetch type as eager. Are you able to follow this? Are you able to follow this? Okay. Now, let us retrieve only child record and see what is happening now. Public void get address. Here we have address repository dot find by ID address ID. Okay. When we are retrieving child record, then what is the behavior? Can you guess the behavior, guys? When we retrieve the child record, parent will come or parent will not come. When I'm retrieving the child record, parent record will come or parent record will not come. Parent record will come or will not come. Can you check that and let me know? Can you think and let me know? Parent will come, will not come. Can we check that one? By removing the fetch type, can we check that one? Okay. Yeah. Fetch type is not available. I'm trying to retrieve the child record. When the child record is retrieved, parent record will come or parent record will not come. Can you guess the answer and let me know in the chat box? Run as boot application. See, I'm retrieving the child. I'm retrieving the child. Now see, only child will come or child plus parent will come. You see here, child plus parent is coming. The reason is, guys, you need to understand. When you retrieve employee record, only employee will come. Why? Because in the employee table, there is nothing related to address. Only employee will come. Because the default fetch type is eager and in the employee table, there is no information related to address data. When you retrieve the parent, only parent record will come because child, this table does not know what is child. Okay. But when you check the address table, when you retrieve the address record, so it is going to retrieve all the columns from the address table, right? There is one column which is employee ID, which is a parent table record. So when you retrieve child, child plus parent will come. When you retrieve parent, only parent will come. Parent is only one. So here, child table record when you are retrieving, child having a relationship with parent, na? So definitely parent also will come when you retrieve the child record. Okay. When parent is retrieved, childs are not retrieved by default. So because the default fetch type is lazy, only parent will come. If we want to retrieve child records also along with parent, then we have to set fetch type as eagle. So then what is the another observation that we had? When we retrieve, when child is retrieved, child plus parent is coming. So these observations you need to keep in your mind, guys. When we are working with relationships, these observations are very, very important. Okay. So when parent is inserted, child also inserted. When parent is retrieved, childs are not retrieved by default because of the fetch type. By default, fetch type is lazy, only parent record will come. By default, fetch type is lazy, only parent record will come. So if you want to retrieve child also along with the parent, then you need to set your fetch type as eager. How do we set the fetch type as a eager? Go to your parent table, and here in this annotation, we are going to specify fetch is equal to fetch type as eager. We are going to specify fetch is equal to fetch type as eager. Okay. So when the child is retrieved, child plus parent is getting retrieved here. Child plus parent is getting retrieved. Now, if I delete parent, then what will happen? If I delete my parent record, then what will happen? Public void delete emp. Public void delete emp. Emp repo dot delete by id. Emp repo dot delete by id 1. I'm trying to delete my record in the parent table. Employee table is a parent table. I'm trying to delete the record in the parent table. Can you guess the behavior now? What will happen if the parent is deleted? Can you tell what will happen when the parent is deleted? Service dot delete emp. Service dot delete emp. When I delete the emp, what will happen? When I delete the parent, what will happen? Child will be deleted or child will not be deleted? Come on, guys. When I delete the parent, then what is going to happen? Let's try. See the behavior of the application now. Run as boot application. See the console. See the console now. When I delete the parent, what is happening? Only parent is deleted or child's also deleted? Child's also deleted. Now you see in the address table, we don't have any record. In the employee table also, we don't have any record. So everything is deleted. When parent is deleted, child plus parent getting deleted. Child plus parent is getting deleted. Child plus parent is getting deleted. So these are the observations. These are the observations that we have when we go for one-to-many relationship. Okay, one-to-many relationship. Parent table record will have multiple records in the child table. When we perform insert, delete, retrieve, these are our observations. Parent insertion, child also inserted. Parent retrieved, child is not coming by default. When parent is retrieved, child is not coming by default. When parent is deleted, child is getting deleted. When parent is deleted, child is getting deleted because without parent, the child record cannot be available. When parent is retrieved, childs are not retrieved by default because of fetch type. Along with the parent, if you want to retrieve childs also, you need to set the fetch type as a lazy. So here, two things we understood. One is a cascade, another one is fetch type. What is the meaning of a cascade? Cascade represents what operations we are doing on the parent table should reflect on the child table. What operation that you are performing on the parent table should reflect on the child table. That will be represented by cascade. Fetch type will represent when to retrieve child records when we are trying to retrieve the parent. By default, it is lazy, childs will not come. If you want childs also, set it as eager. Set it as eager. Are you clear with my point? Are you guys clear with my point? Good. So with this we understood what is the one-to-many relationship. Okay. One-to same example, one-to-many and many-to-one also. If you are coming with the address side, if you are coming with address side, this is called as many-to-one relationship. Okay. Now, suppose I want to save addresses, not the employee. Earlier I have saved parent, one-to-many. Now I want to go for many-to-one. Many-to-one means save addresses instead of the parent. Okay. So let me write the same method again. Save address records. Save addresses. Save address. A1, A2. A1, A2 and association is completed. Save address records. How to save the address records? Address repository dot save of A1. Address repository dot save of A2. Okay. So earlier what we have done? We have associated employee to address, address to employee, and we saved employee. Okay. Now what I am doing? A1, A2 addresses are available, association is available, but I am saving address record. So when I am saving address record, employee will be saved or employee will not be saved. Employee will be saved how many times, guys? This is many-to-one relationship now. Multiple addresses belongs to same employee. I'm saving all the addresses now. I'm saving all the addresses now. So multiple addresses belongs to single employee. When I save two addresses, how many queries will be executed? Last time, when I save the employee, one employee inserted, two addresses inserted. So total 3 queries executed. Now, I'm saving 2 addresses. How many queries will be executed? I'm doing many-to-one operation now. Many addresses belongs to one employee. Okay. So when I save addresses, then what will happen? When I save the addresses, then what is going to happen? Can anyone tell me? When I save the addresses, then what will happen in our application? When I save addresses, then what will happen in our application? Exception. Only 2 queries are. Now you see the data, guys. When I'm saving address, address is having an employee, address 1 is having an employee, address 2 also having an employee. I'm saving 2 addresses now. So what data will be inserted in the table? When I save the addresses, what data will be inserted in the table? Whenever you do this operation, employee will be inserted, two addresses will be inserted. Whenever you say last time's employee having multiple addresses, employee inserted, child's also inserted. Now two addresses will be inserted, employee also will be inserted. Okay, because address is having the employee reference. Run this application, save addresses, service dot save address. I'm saving address. Two addresses I'm saving, both addresses belongs to single employee. Here JPA will work maturely. It will insert employee one time and address records will be inserted two times because two addresses available. It is giving the exception. Insert into address values object references as unsaved instances. EMP employee record is not saved. Transient issue, save address records, save to address records, EMP repo dot save of EMP record dot save of EMP, run as boot application. Now employee inserted, two addresses inserted. It is retrieving the employee record is already available, so not inserting again. Two addresses inserted with employee ID 2. Employee record is inserted with ID 2. So employee record we are inserting and address records also we are inserting when we perform many to one operation. But when you go for one to many, when you save the parent, childs are saving automatically. Here when we are saving only addresses, employee is not available, so records are not inserting. So you need to save the employee first, then you need to save the addresses here. Save the employee, then save the address records. Good. So these are our observations for one-to-many relationship and one-to-one relationship. When we go for one-to-one relationship, one person will have one passport. One parent record will have one child record. One parent record will have one child record. Observations. When parent is inserted, child also inserted in the one-to-one. When parent is retrieved, child also retrieved with the left join. When child is retrieved, parent also retrieved with the left join. When the parent is deleted, child also deleted. When it comes to one-to-many relationship, parent table record will have relationship with child table record. One employee can have multiple addresses. When parent inserted, child also inserted. When parent is retrieved, childs are not retrieved by default because of the default fetch type is lazy. If we want to retrieve child records also along with parent, then we have to set fetch type as eager. When child is retrieved, child plus parent is getting retrieved by using left join. Okay. When parent is deleted, child plus parent is getting deleted. Good. If you look at from employee table, this is one-to-many relationship. If you look at from address table, it is many-to-one relationship. Are you guys clear with this? One-to-one and one-to-many and many-to-one. One-to-one, one-to-many relationship, guys. Yeah. Next one, another relationship is available, which is many-to-many relationship, guys. As we discussed theoretically, many-to-many relationship will be available. What is the meaning of many-to-many relationship? What is the meaning of many-to-many relationship? That is rarely used relationship here when we are developing the application. Many-to-many relationship, nothing but here user table will be available here roles table will be available. Okay, users will be available in one table and roles will be available in another table. So here user ID will be available and the user name will be available and the user phone number you can give. Then here in this role table, role ID will be available, role name will be available. Role ID, role name will be available. Here user ID, username will be available. User ID, username, phone number. Here role ID, role name available. Now to establish this relationship, we need to create one more table which is called user roles table. In the user roles table, user ID will be inserted and the role ID will be inserted, which will represent which user is having which roles in our system. Users data will be available in the users table. Roles data will be available in the roles table. So which user is having which role in our application, that will be represented by using user roles table. That will be represented by using user roles table. So to establish this many to many relationship, 2 tables are not sufficient, guys. We need to go for 3 tables. Many to many relationship. When we are setting up many to many relationship, then we need to go for 3 tables here. User table, roles table, and user roles table will be available. Many users are having many roles. So if you look at user roles table, that means many users are having many roles in our system. Many users are having many roles in our system. Now, when we are doing this kind of operation, so here this user ID will be pointing from this table. This role ID will be pointing from this table. Okay. So user table primary key is user ID. Role table primary key is role ID. User table primary key is user ID. Role table primary key is role ID. So in the user roles table, user ID and role ID will be available. One is join column, another one is inverse join column. This table is called as a join table. Basically, the table which is representing joining the 2 records, user record and role record, this is called join table. This is join column and this is inverse join column. How do we design entities for this? Let us see the designing part of entities. New Spring Starter project. Spring Starter project. I have already given the Git repositories, guys. Same code. JPA, many to many relationship. Now, MySQL driver, data JPA we are taking. Next and finish. Yep, our project is getting created. Good. Take the database properties. YML file is available. I want to keep the same database configuration. We are connecting with the same database. Delete the properties file and YML file will be available. Now, we are going to create entity classes. Okay. So let me create first user class. Create the user entity now. New class user entity in.ashokit.entity. Let me create one user and let me create one more entity which is called role, user table and role table. So in the user table, we are going to take user ID, username and some gender, whatever we want. Private, integer, user ID, private string, username, private string, gender. So this is normal user. Here we are going to represent this as entity. Okay. And here we are going to represent as ID. And here generated value, strategy is identity. We are going to use the strategy as identity because it is a MySQL database. It is a MySQL database. Same concept for the role also, role ID and role name. Private, integer, role ID, private, string, role name. Role ID is a primary key. Let's go for ID, and it is a auto generated value. Strategy is equal to identity generator. Let me represent this as an entity class by using @entity. So currently, any relation between user table entity class and role entity class, guys, is there any association between user and role as of now? No. Now, what is our requirement? Many users can have many roles. Our requirement is many users can have many roles here. So this configuration is little complex, guys. Many to many relationship configuration, because we need to create a third table which is called user roles table. Now, so in order to represent this, many users can have many roles. I'm going to take here private list of roles. List of role and roles we are taking. What is the meaning of that? One user can have multiple roles. When you see from role side also, we are going to represent the same. Private, one role can belongs to list of users. One role can belongs to list of users. Now you see, earlier there is no relation. Now in the user table entity, I'm writing list of roles as a reference. In the roles table, I'm writing list of users, which represents multiple users can have multiple roles. Multiple users can have multiple roles. Now, if you see from user side, user having list of roles. If you see from roles, role is having list of users. So which is many to many relationship. Which is many to many relationship. Now, first coming to the role here, what is the relation from role to user? Many to many relationship, which is mapped by roles. Mapped by is equal to roles. So in the role table, users available. In the users table, the roles are mapped. In the user table, not mapped. Okay. So if you see the user one, roles available. So I'm giving the mapped by is equal to roles. That means, so role table is having reference of user. User is mapped with the roles. User is mapped with the roles. Now coming to the user side, here the configuration is little confusing, guys. Observe carefully. I have list of roles. From the user, list of roles are available. Now, I want to represent the relation which is many to many relation. Cascade type is equal to all. Cascade is equal to cascade type dot all. So whatever the operation you do on the parent will reflect on the child as well. Okay. What about the relationship now? The relationship will be available in a third table which is called user roles table. The relationship will be available in a third table which is called user roles table. So the third table which is representing the relationship, that third table is called as a join table. The third table is called as a join table. In that join table, what are the join columns? Okay, this is going to be my join table. This is one join column and this is another join column. Join table with join columns. So we are going to specify join table. For this join table, what is the name we are going to give? Okay, user and roles available. So for this join table, I'm giving the name as user roles. I'm giving the name as user roles. Then what about join columns? what columns will be available in this table? In this table, two join columns will be available. One join column is available. Join columns. At the rate join column is equal to the column name. What is the join column we are going to specify? User ID is one join column. The next one is inverse join columns will be available, which is role ID. Inverse join column name is equal to role ID. Inverse join column is equal to role ID. So this is the configuration. So here users having roles, here roles belongs to users. So from the role, user is having many to many. From the user, the role is also many to many. User to role, role to user, many to many. This annotation is going to represent a join table, which is a third table where actual relationships will be maintained. Which user is having which roles. That information will be maintained in the third table. That third table is called as a join table. So how do we create the join table? By using at the rate join table annotation. By using at the rate join table annotation, that third table will be created. In that join table, we are going to keep user ID as a join column, role ID is a inverse join column. Okay, good. Now with this our entities are ready. Let us generate setters and getters for this. Setters and getters I am writing, and here also setters and getters I am writing. Guys, whenever you are having entities with this kind of relation, don't write to two-string methods. If you write to two-string methods, you will get Stack Overflow error. In the two-string method, one entity will access another entity, that entity will access another entity. User, now, if you as the two-string method, if you use Lombok, if you use Lombok, if you use at the rate data annotation, what will happen? User entity having the relation with the role entity. This is my user entity. User entity having the relation with the role entity. Role entity having the relation with the user entity. When you access the user, it will access the role. When you access the role, it will access the user. User will access role, role will access user. It is going to infinite loop, guys. Then you will get Stack Overflow error. When you are designing your entities with the relationship, association mapping, don't write at the rate data annotation, because at the rate data annotation will give you two-string method. If you have the two-string method to print the content of the object, user will print role data, role will print user data, then again user will print role, role will print user. It will go to infinite loop here, and the program will run into Stack Overflow error. So that's why manually you write the setters and getters to get the data and set the data. Don't write any two-string methods in the entities when there is a association mapping. If you write the two-string methods when there is a association mapping, then you will enter into Stack Overflow error. Then you will enter into Stack Overflow error. Don't do that mistake. Good. Now look at this one. Here we are considering user ID as a parent, that is a join column. Okay. Yeah. Inverse join column will represent the relationship here. So user table, user ID, role table, role ID will be available. So user ID we are taking as a parent and role ID we are taking as a child. That child one we are going to consider as a inverse join column. Inverse join column will represent, that is the child information that we are storing. Good. Now our entities are ready. Let us setters getters also ready for our entities. Then create repositories now. New interface. One is user repo. Another one is role repository. One is user repo. Other one is role repository. Okay, good. Next one, extend the properties from JPA repository. User and it is a integer. Okay, role repository extends from JPA repository, which is role and it is an integer. Yes, perfect. Go to a service class, new class, user service. I'm keeping this inside the service package. Let us keep this as service. Okay. Now we need to insert the data, right? Multiple users can have multiple roles now. Multiple users can have multiple roles. Let us create one method, save user, public void save user. So for this we are going to inject private user repository, which is user repo, by using @autobiring. First let me set the data here. Role r1 is equal to new role, r1 dot set role name, r1 dot set role name, role we have taken r1 dot set role name. One role I'm taking as admin role. Then role r2 is equal to new role. We are going to take it as a manager role. R2 dot set role name. I'm taking one admin role and one manager role. Admin role and manager role we are taking. Then let us take the user data. User u is equal to new user. U dot set username. Okay, I'm setting the username. U dot set gender. Role ID, user ID will be auto generated. Role ID and user ID will be auto generated. Now, let me set the roles data to the user. Set roles to user. User dot set roles. Multiple roles available. Arrays dot as list of role 1 comma role. Save user, save parent. Okay, that is user repo dot save of user object. User repository dot save of user object. Look at this one. Yes, right. One role object, first role and the second role, user object. For the user, we are setting the roles and we are saving the user. Before that, show tables. Now, as of now, address, employee, passport, person available. There is no table called user table and role table. Let us execute this application. Go to the application. Now, see context object. See the context object. Context dot get bean of user service dot class. So we got the user service object now. User service dot save user. Now, can you guess what queries we are going to what queries are going to get executed now? What queries are going to execute now? Guys, what queries are going to get executed now? Can anyone guess and tell me what queries will be executed now? How many queries and what are those queries? Can you guys guess how many queries will be executed? Can you tell me how many queries will be executed now? Three queries. Check it. Table creation will happen first, then insertion purpose, how many queries? So total here, tables are created, you leave that. Total 5 queries are executed. So one query for inserting the user record into user table, two queries to insert two roles into roles table, two queries to insert user roles into user roles table. Join column table is available, right? So total 5 queries got executed. One query to insert the user record into user table, two queries to insert user roles data into roles table, and user roles information will be maintained in the third table. So total 5 queries got executed. Look at the 5 queries which are executed there. Yes, check the data in the tables, show tables. Now you see user role table, user roles table. User table will contain the user information as we see in the diagram. Role table will contain the roles information. User roles will be available in the user roles table. User roles table is a join table where the actual data representation will be available. Now check the data in the tables. Select a star from user. Yes, user ID, username available. Select a star from role. Role ID, role name is available. Select a star from user roles. First user having role 1 and role 2. User ID is having user ID 1 is having role ID. User ID 1 having role ID 2 also. User table contains user information. Role table contains role information. User roles table contains the relation between the users and roles. This is many-to-many relationship. One-to-one, one-to-many, many-to-one, and many-to-many relationships. Okay. Many-to-many relationship. User table, role table, and user roles table. Multiple users will have multiple roles. Multiple users will have multiple roles. Users data will be there in the user table. User table contains users information. Contains users data. Role table contains roles data. User roles table contains relation between users and roles. Multiple users will have multiple roles. To represent a relation, we will use start table, which is called as a join table. Which is called as join table. Join table contains a join column and inverse join column. Join table contains join column and inverse join column. Inverse join column means child table ID. Join column means parent table ID. Inverse join column means child table ID. Are you guys clear? Association mapping example. And remember one point, don't use @data and toString methods in entities. Don't use @data and toString methods in entities. When we use these things, if we use toString method, if we write toString method in entity which is having association mapping, then we will run into Stack Overflow error. We will run into Stack Overflow error. In the Java, errors cannot be handled. Your program will be terminated. Why it will run into Stack Overflow error? So here you are having employee table and address table. Here employee entity having the reference of the address. Address table, address entity having the reference of employee. When you get the employee, toString method if you access, it will call the address. Address also having a toString, it will call employee. Employee will call address, address will call employee. Employee will call address, address will call employee. This process will be repeated forever and program will run into out of memory problem. Okay guys, so when you are using data, then toString method will come with the data. Or if you manually write the toString method, one entity will have a reference of other entity, so they will be calling each other forever. When they are calling each other forever, then your program will run into out of memory error. So don't write the toString methods when your entity classes are having a relationship like this. You can't handle the error in the Java. Don't write the toString method, then that error will not come. Got my point? Good. So with this we understood association mapping concept. Let me upload these notes in the portal. Git repository is already shared with you people, so you can do the practice of this coding part. And it's important to understand how the relationships will be established for the tables and how we are going to represent those relationships in our entities. How to establish relationships in the tables and how we are going to represent those relationships in our entities, that is important concept. So most of the times in the project, one-to-many relationships will be available, guys. Most of the times we are going to use one-to-many relationships among the tables in our application. One record in the parent table will have multiple records in the child table. The notes is updated in the website. Could you please check it and let me know? Is it accessible for all of you? Could you please let me know? Is it accessible for all of you? Yeah, perfect, guys. Good. Yeah, guys, anyone having any questions? You can unmute and you can ask me now.
Yes, sir. I have a question. So if you take
Yeah.
passport table and the passport applied person table, okay?
Yeah.
The- Okay. The person has got the passport, okay, and the passport got expired, okay.
Okay.
But we want to renew now. The passport number will be same, but how the mapping will be, whether it is one to many or one to one only in this case.
Sir, passport is expired. Passport status will be available. Is it active status or expired status? When the passport is expired, just status will be updated in the same record. It's not another record in the table. Okay.
Okay.
When you have go for extension of the passport, then the passport another column will be available. Passport renewal got completed. Your new expiry date will be updated in the table. That's it. Same record will be updated with the values.
But
Hello,
they
sir.
will also maintain the old record as well, right, sir?
So that will be comes under auditing part, sir. They will maintain another table. So before updating the existing record, the whatever the record is already present in the table, it will go to auditing table. Then they will insert the new record, or they will update the existing record.
Hello,
Okay.
sir. I'm
In
audible.
this scenario, we need to maintain 3 tables while designing itself, you mean?
Auditing table we need to maintain.
Okay. Got it, sir. Thank you.
Hello, sir. I'm audible.
Yes, sir.
Sir, please reshare this GitHub link now for this user mapping, please, in the group. Hello.
It is already there. I will reshare
Yes,
that.
sir. So I'm not finding it. It's not in the notes probably. It's in the group probably. So if you
I will add that in the notes and I will upload that, sir.
in the notes you have added, sir.
I will do that. Not added, I will do that.
Okay, sir. Thank you.
Hi, Ashok. When we are using one-to-many, right? So parent and child. So one parent has two addresses like permanent and present, right? So
Correct.
whenever we to delete unnecessarily present address, we need to delete from the particular child only. At that stage, we
Child record you can directly delete it, sir. No problem, because
but
you can
it is
directly.
affected on the parent also, right?
No, it will not affect on the parent because already there is two childs available. You are deleting one child. Parent will not be affected.
Yeah. Okay. Hello.
Hello.
Yes, sir.
Hello.
Actually, in microservices thing, right? How can we implement this relationship association mapping in our project? Because all entities are in different APIs, right?
When you have entities in the different APIs, what relation you want? That means, so if you are
The foreign key,
want,
we manage the database design foreign key relationship, right? That one, how can we include in our project?
listen to me. When you are going for microservices architecture, microservice want to communicate with the multiple tables which are having the association mapping. Those entities you need to keep in the microservice.
In each API, we
The
need to keep whatever the
whatever the entities are there now, the duplicate entities you need to keep in the multiple microservices where you want to establish the relation.
Okay. Thank you, sir.
Hello.
Yes.
Sir, if I want to insert only parent, then how, sir?
Don't set the child data. We are associating the childs to the parent, right? Don't associate that. Just you set the parent record data, you insert parent record.
Tasks for
When we are,
child also, no, sir? And we are taking the variable, right?
No, man. Here, whenever you want to insert only parent record, we are setting the child data to the parent object. Now, don't set the child data to the parent object. You just create employee object. You set the data for only employee ID and employee name, and you say only employee. You don't set addresses to the employee. Then only parent will be inserted.
Sir, how to overcome that two-string error, sir? How?
Error you can't overcome, sir. You can't overcome the error. Don't write the two-string.
So then we should not use Lombard, sir.
Yeah, we should not use Lombard. Yes.
So at the rate data, what it will do? Like similar to two-string, it will keep calling.
It will add the setters, getters for your variables. It will add the zero param constructor. It will add this string method also for your variables available in the class. So don't use that Lombard annotation when you are dealing with association mappings.
Okay.
Sir, sir,
Yeah, hi.
without toString, how can we print data, sir?
How can?
We print data in the console.
In the real time, we don't print the data on the console, no?
Yes, sir.
But then what is the use of the toString? We don't print data on the console. We'll send the data as a response to the UI, or we'll send the response as a JSON. We don't print data on the console. If you want to print the data on the console, you call the getter methods. Getter methods already available.
Sir, you are taking one user. He is having two roles. Then we call the one-to-many relationship.
Yeah, if you see from that side, it is one-to-many. You can create one more user. You can set the roles, and you can insert two users. Then many users, many roles will happen.
Okay. But you are taking only one user, no, sir?
I have taken one user. You can take two users also.
Okay, okay. Thank you, sir.
Hello, sir.
Yeah, hi.
Sir, in our project, are we going to use association mapping?
We have to. I already gave the table design, so we need to set up this association mapping.
Okay, but there are the different APIs. Then how can we do that?
Entities will be common, sir. Whenever you go for microservices, which they want to communicate with the same database, entities, whatever the entities you are designing, those entities will be there in all the APIs.
Okay.
Whatever the entities we are writing, those entities will be available in all the APIs.
Hello, sir.
Yes.
Hello. Yes, sir.
Yeah,
Even without having entities in the like different microservices, we can also use query for that. No? Directly we can do this.
If you don't want to do that, if you don't want to keep all the entities, then you need to write the native SQL queries with the joins to retrieve the data.
Yes, sir. That's what I was saying. We can also do that way.
Yeah, you can write the native SQL queries to retrieve the data.
Okay, sir. Thank you.
Sir,
Yeah, fine, guys. Yeah.
For example, if I have three screens, in the first screen, I need to save user data. In the second screen, I want to save the current address. In the third screen, I want to save the permanent address. So how we can do that?
Whenever first screen is submitted, you will save only employee data. When the second screen is submitted, you will save the address data by setting the existing employee record. In the third screen also, you will get the address. For that, you need to retrieve the employee ID and you need to set that. So whenever you are saving that child record, right? Child record should have the reference of the parent record. Address.set employee. That employee ID, you need to set it. When you are having three screens, you need to maintain the employee ID in the remaining two screens. You need to set the employee ID to the address object, then only you will save the address object.
Sir, for this, how many methods we need to require?
You need to write. One is for saving employee, two methods are saving two different addresses.
Okay, sir.
Yeah. Fine, guys. Good.